Hey guys, in this video we're going to be doing the first K concept, which is key concept 1. Obviously you have all the hints right here of where you can look back in the note packet. Kind of a refresher of everything we did in KC1. So our first question here, we have x to the 1/5 times x to the 1/3 times x to the 4/5. So notice we're multiplying our bases here, and they're all the same base. So if you're multiplying and everything has the same base, what you can do is just add the exponents. So you're going to add 1/5 plus 3/5 plus 4/5. It's going to give us x, and we notice that the denominator is all the same, so that does not change, and we just add the top. So 1 plus 3 plus 4 is 8. So our answer is going to be x to the 8/5. Next example, we see that example of the power rule. So remember that when the exponent is on the outside, you have to multiply. Also, that 100 has its own exponents. So 1/2 times 1 is going to be 1/2. So therefore, I'm going to have 100 raised to the 1/2 power. 1/2 times 14 is going to be 7. So n to the 7th power. Anytime you have a base that you do know, please simplify that in your calculator. 100 to the 1/2 power is 10, n to the 7th. Okay, so a note here, make sure that you know that this is an exponent, right? So use that little caret button on the calculator. You're not multiplying 100 times a half. It's an exponent. Number 3, we're multiplying all of our terms here. So basically you can take all those like terms out in the front. So what I'm going to do is I'm going to bring all the coefficients to the front. So 6, 2, there is that imaginary 1 there if you want to bring it out, and 7. So therefore I'm going to have 6 times 2 times 7. I'm not going to write the 1 because anything times 1, it doesn't really change what my answer is. Then I'm going to look at my m's. M and m. So m to the 5/7. Since I'm multiplying, I'm going to add those exponents. And then I'm going to do the same thing with my n's. So n to the 1/3 plus that 1/4. Alright, now we can go ahead and multiply all of our answers out together. So 6 times 2 times 7. Don't forget to add the exponents on m and add the exponents on the n as well. So 6 times 2 times 7 is going to give us 84. Let's make sure I'm in the right color here. So 84. My m, I have, again, I'm adding fractions, so like denominators. 5 plus 2 is 7. My n, 1/3 plus 1/4. So yes, you can do 1/3 plus 1/4 in your calculator by hand. I'm going to go ahead and show you guys how to do that over here. So they're not like denominators. The like denominator that they each have, though, is 12. So what I need to multiply 4 by to get a 12 is times 3. So 1 times 3 is 3. How do I get from 3 to 12? Well, this one I'm going to be multiplying by 4 over 4, right, which is 3 over 3. And this is going to give me 4. Now that they have those like bases, you can just go ahead and add the tops. So this is going to give me 7 over 12. Again, if you want to put it in your calculator, feel free to. You don't get any extra points if you do it by hand. Alright, so my final answer then, 84. M to the 1st power, n to the 7/2. Again, I don't really need that 1 there for my m, but you can write it. Alright, so this is going to be my final answer. Some of these questions should look somewhat familiar because they were on the review for that unit. Alright, example number 4, rewrite the following expressions using rational exponents. So, if you are in radical form, remember that everything underneath the radical is the base. So I'm going to keep that base together, 10d. Then I'm going to take my exponent, and that's at the top, and my root is at the bottom. Alright, all it's asking me is to rewrite it. Okay, so making this look a little bit more like an exponent, I'm going to write 10d and then 2/5 is an exponent. All right, number 5, rewrite the following expression in radical form. So before we write in radical form, what we should say is simplify, then rewrite it. Okay, so we want to simplify first. So we're going to do the same thing as we did in example number 3, where we're going to take those coefficients out first. So 5 and 6. 5 times 6. My y's, I have that 1/3 and that 3. I'm multiplying, so I'm going to add those exponents. All right, 5 times 6 is going to give me 30. Y, if we are going to add 1/4 and 3, we have to come up with like denominators. So I'm going to do that part over here on the side. So 1/4 plus 3. 3 is like 3/1. So having like denominator is going to change both of them to be a 4. So my first fraction doesn't change, 1/4. But 3, I'd have to multiply by 4/4. So therefore that becomes 12/4. When I add my numerators now, I get 13. So this is going to be 13/4. Now I have to go back and rewrite it into radical form. So remember, anything that does not have a fractional exponent is going to stay outside of our radical. So I know my radical is going to be here. My 30 though is going to stay outside. My y is going to go inside. Just like before, this bottom number is my root, and the top number is going to be my exponent. So please make sure you either write it on the top or put the y in parentheses. We don't want to see it right next to it, just in case we have more than one term underneath our radical. Alright, next one, rewrite the following expression in radical form. So kind of what we just did in the last example, all I have to do is rewrite it. So I have my radical here. I know my base is 13. I'm going to take that root number, which is 7, so that's going to be out here. And then my exponent was a 4. Target C, all about making decisions about rational and irrationals. So number 7, evaluate and determine if the solution is rational or irrational. When we are multiplying radicals, the only thing that needs to be in common is the same root. So when multiplying, what you have to have is the same root, which they do, right? Each of these have that invisible 2. So then I can combine them under one radical, which is the square root of 36, and the square root of 36 is 6. This is a rational. Why? Well, because it's an integer. Alright, a little bit different on number 8 because it says to determine if the solution is rational or irrational, but now we are adding. So when adding, we have to have the same root and the same radical. So when adding, or you can even think subtracting, you need to have same radical. And the same root. So, well, they each have a root of a 2, and they each have, underneath our radical, our base is a 7. So what we add here is the coefficients. So remember, add coefficients. So what's in front of the square root of 7? There's a 1 there. What's in front of the other one? It's also a 1. So therefore my answer is 1 plus 1, which is 2. Don't forget my square root of 7. Is that answer rational or irrational? This would be irrational. Well, why? Not a perfect square. Right? There is no square root of 7. That is a decimal, so therefore it is not a perfect square. Alright, last section for KC1 is target D. This is when we had to solve when our exponents were unknown, right? We have to make sure that we have like bases. So the first thing is, well, I have x to the 4 to the raised to the x power, and then I have 32, And I have to figure out how I'm going to rewrite each of these. So looking at your powers cheat sheet, you would probably look at the powers of 2 because 32 can't be rewritten as a base of a 4. So in this case, you have to rewrite both of them. 4 can be rewritten to be 2 to the 2nd power. And 2 raised to what power is going to give us 32? Well, looking at the powers cheat sheet, 32 is going to be 2 to the 5th power. And again, if you need some help with this, please go back to 1D.2 or you can rewatch that video on our Common Core webpage. Alright, so now I'm going to rewrite what I have. So that 4 can be rewritten as 2 squared, but I can't change the exponent that was already there. That's still part of it. 32 can be rewritten as 2 to the 5th power. Now that I have like bases, I can go ahead and set my exponents equal to each other. So remember, when the power's on the outside, we multiply. I'm going to go ahead and kind of extend this over here. So here I have 2x equals 5. I want to get my x by itself, so I have to do the opposite operation. Since this is getting multiplied, I'm going to divide on each side by 2. So my final answer here is going to be x is going to equal, leave it as a fraction please, 5 over 2. Alright, last one for KC1. Similar, except for we don't have to change both sides, right? I have a base of a 3 and a base of a 27. 27 can easily be changed into a 3. So I'm going to go ahead and rewrite that, right? Looking at your power sheet. 3 to what power is going to give me 27? So 3 to the 3rd power is going to give me 27. Again, you can't change the value of what you have on each side. All right, so we're going to rewrite the left side. Y over 7 minus 1 is going to equal 3 to the 3rd power, right? Because this can be simplified to what we just did over here. Now that we have like bases, we can go ahead and set the exponents equal. So bring the whole exponent down. Y divided by 7 minus 1 is going to equal 3. Next step is to isolate the variable. So I need to add 1 on each side. And that's going to bring me over here to be y divided by 7 equals 1 plus 3 is going to be 4. Then I want to do the opposite operation. So what's the opposite of dividing? Opposite would be multiply by 7 on each side. So therefore, I have x is going to equal 4 times 7, which is 28. All right, that brings us to the end of KC1. And you can rewatch it, go back to those notes. And then the next video is going to pick up on KC2.